This lesson looks at what happens when brine undergoes electrolysis. You may need to look at our lesson What Happens in Electrolysis before going any further. The electrolysis of brine is an industrial process which is carried out on a large scale, but we can look at the process on a smaller scale in the laboratory. Brine is a saturated solution of sodium chloride. We don't want the electrodes to become part of this reaction, and so we use carbon electrodes. From the sodium chloride, we have positive sodium ions, Na+, and negative chloride ions, Cl-. And from the water, we have positive hydrogen ions, H+, and negative hydroxide ions, OH-. When the current flows, you will begin to see tiny bubbles of gas forming at each electrode. Both hydrogen and chlorine gas are formed. But can you work out which electrode produces which gas? Pause the video and see if you can work it out. The chlorine is formed at the anode, that's the positive electrode, and the hydrogen is formed at the cathode, that's the negative electrode. Did you get it right? Let's look at what's going on at each electrode. The anode is positive and attracts the negative chloride and hydroxide ions. The chloride ions give up their electrons to the anode and are oxidized to chlorine molecules. 2 ions need to be oxidized to make a diatomic chlorine molecule, and 2 free electrons are produced. The electrons are given up to the anode and the chlorine gas bubbles up to the surface of the cell. If you collected the gas from the anode in a test tube, then you would be able to see the pale green colour of the chlorine gas. It will turn damp blue litmus paper red, showing that it is acidic, and then it bleaches it. Well, what about the cathode? It is negatively charged and attracts the positive sodium and the hydrogen ions. The hydrogen ions each gain an electron from the electrode to form hydrogen atoms. Here's the equation. 2 hydrogen atoms then bond to form a diatomic hydrogen molecule, and that's the hydrogen gas given off. The gas here is colourless and can be collected in a test tube. The test to prove that it is hydrogen is done with a burning wooden splint, and you'll hear a familiar pop as the hydrogen burns. The ions left in the solution are the positive sodium ions and the negative hydroxide ions, which combine to form sodium hydroxide. Overall, the electrolysis of brine has produced hydrogen, chlorine, and sodium hydroxide, and so we can write a summary equation. Concentrated sodium chloride solution plus water, when electrolyzed, gives sodium hydroxide solution, hydrogen gas, and chlorine gas. These products are very useful, and the electrolysis of brine is done on a much larger industrial scale. Chlorine is used to kill bacteria, and it is soluble in water. If you've ever visited a public swimming pool, then you'll be familiar with the smell of chlorinated water, and it's also used to sterilise water in the mains water supply. What's more, chlorine is one of the main ingredients of bleach, which is used in a lot of cleaning products. But this is only scratching the tip of the iceberg, as chlorine is used to make dry cleaning ingredients, electrical insulators, building materials, refrigerated gases, weed killer, pesticides, antiseptic disinfectants. Some of the hydrogen and chlorine from the industrial process is combined to form hydrogen chloride gas. It's a rather unpleasant gas, but it dissolves in water to produce hydrochloric acid, which is a very useful acid. It too can be used for cleaning metal, but it is also used for producing chloride salts. Sodium hydroxide is another cleaning product, and the most common use for it in the home is for cleaning ovens and unblocking drains. That's a rather amazing collection of uses from our original brine,